I am Mr. Bishop, waving to you with my Bitmoji right there. We are here for our very first finite math video. We're going to talk about a couple of the topics that we'll cover, and then we'll go ahead and look right at the worksheet, do a few problems from that, and then that'll leave you with a few problems to do on your own. So this is Chapter 3, Day 1, the very first day, and the topic we're going to cover is linear inequalities. And that should sound pretty familiar to you from your Algebra 2 days, right? You've probably done a bunch of graphing and shading, so I want to start with that. So we're going to be graphing and shading these linear inequalities. For example, I might give you something like y less than or equal to 2x minus 7. So hopefully you recognize that this inequality is sort of in slope intercept form, right? And you could successfully graph that and then shade it below the line since its y is less than or equal to. And that should be sort of a review for you. And then we'll talk about systems of linear inequalities, which just means more than one. There'll be multiple for us to graph. So in a system of linear inequalities, we might have 2 or 3 or 4 individual linear inequalities that we want to graph on the same graph. So for example, y is greater than or equal to 5x plus 9, y is greater than or equal to 3x minus 2, y is less than or equal to x plus 11. And then we'll use this curly bracket thing so we know that they're all three together. They're supposed to be on the same graph. And then once we've graphed a system of linear inequalities, we want to know what the solution set is for that system, and we call that the feasible set. So a feasible set is just all the points that simultaneously satisfy. That means that satisfies all of these inequalities at the same time. So all the points that simultaneously satisfy every inequality of a system. So to be in the feasible set of this system, whatever xy point you use, when you plug it in for x and y, it has to be true for each one of these linear inequalities. And last but not least, we'll talk about when we shade, whether we want to shade true or shade false. And for the examples that I'm going to show after this, we're really going to focus on shading false, right? So when you typically shave above, we're actually going to shade below. We're going to do the opposite. And I'll talk about why that is when we get there. So let's go ahead and take a look at the day 1 worksheet. I've marked the very first problem here, number 31, as one that we'll do. And all we did was copy these right out of our textbook. All right, and our students don't even get a textbook. When we assemble these worksheets, right, it's like we've done the work for them. We just wrote them down right out of a textbook. So if you don't have a printer, that's no big deal. You could just write the problem and then make some axes and graph it from there. Right? So it's no big deal if you don't have a printer. All we did was write these down from the textbook anyway. So this should just knock off the rest for you a little bit. How do we graph and shade y is less than or equal to 2x plus 1? It is in that slope intercept form, right? And the y-intercept would be the 1. So if we look at the y-axis, we want to start right away by putting a dot at 1 on the y-axis. There's our very first point for our line, and we really only need 2 points to make our line. So to move away from that point, we'll use the slope, which is the number on the x. So our slope is 2, or you could call that 2 over 1, which means it's the rise over the run. So we're going to go up 2 and over 1, up 2, over 1, and put our next dot. I'm going to erase those marks there. Up 2 over 1. There you go. You only need 2 points to make a line. Let's go ahead and add our line in right here. And I'll give you a second to do that. So we've got the slope. Use that with the intercept. We've got our 2 points. And we're going to go ahead and practice our shading method. I want you to shade false here. So if I ask you to shade false and it says less than, well, when you think less than, you typically think of less than the line. All right, to think about this as the roof of a house. So less than the roof would be underneath. But if I'm asking you to shade false, well, that means I want you to shade actually the other side. So instead of shading below, like the true form, we want to shade above here. So let's shade above the line to shade false. We're just going to practice that for now. And you'll see why that actually is a really clean result when we start graphing multiple inequalities. And don't worry, sometimes it's not me writing really fast like that. I program these notes before I record them, so the speed which I play them back is not always just how I'm writing them, okay? So I'm not just like a really crazy fast writer, just so you know. And then I want to talk about number 33. It says x is greater than or equal to 2. And that does seem simple on the surface, but it's on us to remember, is that supposed to make a vertical line or a horizontal line? And if we just think about it in a little bit simpler terms, how about just x equals 2? If it's x equals 2, we know we can put a point on the x-axis at 2, right? So there's the x-axis. We can put a dot at 2. And then one way to think about it is no matter what y equals, x will be 2, right? So I could just make a vertical line here at x equals 2. So no matter what y is, x is going to be 2. So I can go ahead and make that vertical line. But if you forget that, or that's hard for you to follow, I did learn this from a student last year, a little acronym to figure out how to graph vertical or horizontal lines that are either x equals or y equals. So if you've heard this acronym before, that's great. It's HOYVOX, H-O-Y-V-O-X, HOYVOX. And those letters stand for horizontal on the y-axis, vertical on the x-axis. So, for example, if I told you to graph x equals 2, you know you need a vertical line on the x-axis at 2. If I said graph y equals 5, you know you need a horizontal line on y equals 5. All right, so HOYVOX, it's a nice little acronym to help you remember how to make those vertical or horizontal lines. And last but not least, before we forget, we still need to shade this thing, right? And I'm going to emphasize again, I want you to shade false. Now this says x is greater than or equal to 2, so that would typically be all the numbers here to the right, but since we're going to shade it false, right, that's what we're practicing right now, I want you to do the opposite and shade it to the left. So as long as I claim, listen, I'm going to shade false, I'm going to go ahead and shade this thing to the left. That's as best as I can shade with my iPad drawing tools. All right, so we've practiced a couple inequalities. We've practiced shading false. Let's go ahead and move on to number 43 here. So number 43, we've got two different inequalities to plot on the same graph, right? And that's called a system of inequalities. And these shouldn't be too bad. We've got y is less than or equal to 2x minus 4, and y is greater than or equal to 0. I like to color code these things, so I'll do the first one in purple there. All right, so let's make that line right away. We've got it in slope intercept form here. The y-intercept would be at -4, so let's go right away to the y-axis and put our first dot at -4. Remember, we only need 2 dots to make a line, so let's use the slope of 2 to move away from that point. So we're going to go up 2 and over 1. Up 2, over 1, put our second dot. I'm going to erase this mark right here. There we go, 2 points, and now let's put our line down. Excellent, and we'll shade this in just a second. Let's get the other line up here too. So I'm going to do the second one in blue there. It's y greater than or equal to 0. You know it's going to be either a horizontal or a vertical line. You probably know which one, right? You could use HOYVOX, horizontal on the y-axis. Let's go ahead and put a point right at y equals 0, right there at the origin. I'm going to do it in blue. And then since it's on the y-axis, right, we're talking about y equals 0. We're going to make a horizontal line in blue here. There we go. So I really just sort of highlighted the x-axis there with my y equals 0 line. And then let's go ahead and practice shading again. Again, we're going to shade false for both of these. So for the purple one, if I shade false, it's a less than sign. So I want you to do the opposite of that, which means you should shade it above. So for the purple one, we're going to shade above that line. Here we go. And for the blue one, since it's greater than, and I'm asking you to shade false, well, then you're going to shade below the line. So let's go ahead and shade this stuff right here below the line. Okay, and here's the result. Since we shaded false, our feasible set, right, our solution will be in this open area here. So our feasible set or our solution, all the points that work for both of these inequalities will be in this open area, which is, in my opinion, a very clean and nice way to go about illustrating your feasible set. Now to make that happen, though, I've kind of put some yellow highlighter here. To make that happen, though, again, you have to shade false. It's also ideal for me as the teacher most of the time when kids are shading things and then turning in their homework to me. I can tell if they say, hey, I shade false, well, now it's obvious to me that the open area is their answer, where sometimes kids aren't that good at shading. They've just got some pencil here and some pencil here, and it's difficult for me to tell whether they've overlapped correctly or not. So when kids shade false, it's really great for me to be able to see, oh, this is the feasible set right away. That's their solution set. Bingo. All right, so I really only want to do maybe one other problem here with you before you finish the rest of this worksheet on your own. Looking ahead, number 45, you've got a system of inequalities. I just want to give a little hint. Those x greater than 0 or y greater than 0, remember to use Hooyvox, right? And what's funny is those two inequalities show up so often. These two right here, x greater than or equal to 0, y greater than or equal to 0. They seem simple, but when we start doing some applications with this, they're on almost every single problem. Basically, this forces us to not have any negative values. For example, if we're selling X hamburgers and Y hot dogs, right? We can't have negative hamburgers and hot dogs. We have to sell 0 or more. So the only other thing I want to emphasize with number 45, other than the Hooyvox thing and graphing those lines, is remember you're going to shade false for these, right? Shade false so that when you're done, your feasible set, your solution set, is an area I can see that's blank. All right, and then the last problem I want to take a look at is the last problem on the worksheet, and really just starting to set up what this graph's going to look like. So it looks like we've got some big numbers here. So right away I'm thinking we might have to scale our axes a little bit differently. Let's go ahead and put these into slope intercept form before we graph them. So again, I'm going to color code. The first one I'll do with purple. And our goal is to get y by itself here, which should be pretty manageable, right? We just have to make two moves. Subtract 6x on both sides, and then divide through by 3. So if I subtract 6x on both sides here, I'll get 3y is less than or equal to negative 6x plus 96. And then again, we want y by itself, so let's just divide everything through here by 3. Divide by 3, divide by 3, divide by 3. And our final result here will be y is less than or equal to negative 2x plus 32. And we'll graph that in just a second once we get the other two lines. The second inequality there, I'll do that one in green. That's easy. That's only one move to get y by itself, right? Just subtract the x on both sides. There we go. We've got y is less than or equal to negative x plus 18. And the third and final one there, I'll do that one in blue. Let's see, we got to subtract 2x first. So subtract 2x on both sides. And then to get y by itself, we'll need to divide everything through on both sides by 6, which gives us y is less than or equal to negative 1/3 if we reduce that fraction, x plus 12. So if you count the tick marks on my graph here, and again, you can make your own graph at home, I guess as big or as small as you'd like. Mine only goes up to 20 on each axis. So since I've clearly got to go up to at least 32 here for this y-intercept, I'm just going to count by 2's, because then that'll get me to 40 on my axes. So I'm going to scale these, count by 2, so that means 2, 4, 6, 8, there's 10. Let's keep going. 2, 4, 6, 8, there's 20. Keep going. 2, 4, 6, 8, 30. And 40. So I'm going to count by 2's here. And that's an important skill, right? If you need to fit things on a graph, you can always rescale it. Just make sure that your x-axis matches that scale too. So let's do the same thing on the x-axis here. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. And all the way to 40, counting by 2's. Alright, so let's start graphing these, starting with our purple inequality up top here. Our y-intercept is 32, so since we counted by 2's, let's go ahead and put a dot up here at 32. There's a purple dot. And our slope is negative 2, so that means we're going to go down 2 over 1, right? So down 2 over 1, put a dot, and let's go ahead and continue that trend across the graph here. Down 2 over 1, down 2 over 1. And that way, since you're putting all these dots down, we might be able to see exactly where some of these lines cross. There we go, all the way down to the axis there. And let's put our line down. I really feel like the Bob Ross of drawing lines right now because of all the color and sort of my approach to this. So if you don't know who Bob Ross is, you need to go look him up right now. Actually, scratch that, finish this video, then look up Bob Ross later when you have a chance. Anyway, never mind that. For those of you that do get it though, this is how I feel right now, making all these lines in color and shading this thing. By the way, this is the extent of my artistic ability. Let's get to the green one here, the second one there. Y is less than or equal to negative x plus 18. So let's put a green dot at 18. And then the slope is negative 1. That's easy enough. We're going to go down 1 over 1. And let's put this whole line on here. And yes, it does cross right there. So that's a nice result that you can see exactly what coordinates those two lines cross at. And all the way to the x-axis, let's make the line. By the way, if you didn't want to do all the algebra and put these into slope intercept form, you didn't have to, right? You could always just solve for the y-intercept and the x-intercept for each line. If you remember from Algebra 2, all you do is plug in 0 for y to get your x-intercepts, and plug in 0 for x to get your y-intercepts. So if you wanted to just do x and y-intercepts, you can do that too. But now we've already got them in slope intercept form, so we're going to go ahead and graph these and plot the points across and see maybe if we can tell where they might intersect. So the blue one there, let's start with a blue dot at 12 at the y-intercept. And there we go. So we've got our blue dot there at 12, the y-intercept, and then it's down 1 over 3 because our slope is negative 1/3. So let's go down 1 over 3, put a dot, and let's finish this off here. Down 1 over 3, down 1 over 3, all the way to the x-axis there. And then go ahead and draw a line right through those points. All right, and then before we get into this mess of shading, let's handle these two sneaky inequalities right here. X is greater than or equal to 0, y is greater than or equal to 0. So I'm going to do both of those in gold, this gold color. And remember, we're going to shade false when we do our shading. So let's start with a horizontal line here, right? Y equals 0. Hoyvox tells us that if it's y equals 0, that's a horizontal line. And then a vertical line for x equals 0. And since we're shading false, we're going to shade below both of these lines. So for y equals 0, right? Since it says greater than, we're doing the false of that. We're going to shade all the stuff below this y equals 0 line. And for the x equals 0 line, we're going to shade everything to the left of it, right? All the stuff less than 0. So we're shading false here. And I want to point out that these two, I think I mentioned it earlier, these two are on almost every practical application that we use. It forces us to work in quadrant 1, where everything's positive. Or at least non-negative, I should say, right? It could still be 0. All right, so let's finish this masterpiece. For the purple one, since it says less than, and we're going to shade false, we're going to shade everything above that purple line. The green one is also less than, and since we're shading false, we're going to shade everything above the green line here. There we go. And the same thing for the blue line, it's less than, so we're also going to shade everything above the blue line because we're shading false. Wow, I'm really proud of how this turned out now. I'm glad I thought of Bob Ross and was able to find this Bitmoji just to add a little bit of character to this problem. All right, so the whole point of doing all that is now we can identify the feasible set. Our solution set is none of that nasty shading. Since we shaded false, our solution set, again, is really clear. It's that open area. So the feasible set, and I'll highlight it again here, is this open area, which is really nice looking, right? Makes your teacher happy. They don't have to see how well you shaded or whether you shaded. It's just this open set since we shaded false. So now all the heavy lifting is done. That makes the rest of these questions actually relatively simple. So the question asks whether these points are in the feasible set, right? So that's our thought right now. These 4 points, are they actually in the feasible set? And since we made it open and empty, it's really easy to tell and see what points are in there. Right? So this is just a simple yes, no for each one of these questions. But I want to caution you, maybe some of them aren't as easy as you might think. For example, they might be close to the lines here, and you might not be able to clearly tell if it's inside this region or not. Some of them are really easy though, right? For example, if I asked you whether the point 4, 4 was in there, you'd say, yeah, obviously 4, 4 is in there, right? It'd be right there. Since we counted by 2's, right, 4, 4 would be right there. See, 2, 4 that way, 2, 4. So 4, 4, obviously you'd say yes, that point's in there. But if you can't tell just by looking at the graph whether a point is in the feasible set, then you need to go and actually do a little bit of algebra. You need to plug in those xy coordinates to each one of the inequalities above and see if it's actually true for all 3. So my last note to you here, if you can't tell whether a point's in the feasible set, like maybe it's really close to being on the edge, you have to see if the point satisfies all the inequalities. So if, for example, if you plug in 8 for x and 7 for y, because this is an xy point, does that check out in all the inequalities up here. Otherwise, it's a yes/no question. All right, so to summarize the lesson here, we talked about graphing and shading inequalities, what a system of inequalities is, what the feasible or solution set for a system of inequalities is, and shading true versus shading false, and why Mr. Bishop prefers everyone to shade false. The rest of the worksheet problems are for you to finish. Thanks for watching.